Good evening. Hope you are fine. Today we are coming back to our class, but before we commence, I want to remember our candidates of the year 2021. They are going to sit for the exam as from tomorrow. For those ones who are doing subjects like French, uh, home science, etc. From this particular channel, we really love our candidates. We wish them the very best in the upcoming exam. All I can say is that if you are the candidate who is going to sit for this exam, know that the exam you are going to be given, it is the same exam that you have done before. The only difference is that the exam that you have been doing was pairing the name of your school, but now the exam you are going to sit for is going to pair the name of NEC. So the difference is just that the name. It is just the same exam. You will see normal topics like fractions, pairing, quadratic expressions, etc. coming in that particular paper 1 and the paper 2, the way we said in our talk yesterday. So these things are the ones that will appear in an exam. So be very focused, be very determined, and remember that you are supposed to enter in any particular exam while having confidence that the exam I'm doing is not something new. It is something that I've already learned, is something that I've already seen before. May God bless you as you prepare for that particular exam. Remember, when you pass, you grant us joy and happiness. So we count on you. Welcome back to our class. I know as you revise for your exam, this particular channel is going to help you a lot. So like today we are going to look at further logarithms, which is a continuation lesson of what we discussed last time. So that's why I've written example 1. I've gone direct to examples because in our previous lesson, I gave you the basic knowledge on further logarithms. So I've written 2 examples here. So from these particular examples, we are going to achieve our objective of computing using logarithms. So let's go direct to calculations. I will say solutions and then start from the first example A. When you look at the example that we are given, the first term is having log 5, the next term is having log 5, but the other term is just a 0. So we have to change this 0 from being a number to being a logarithm. So how do we do that? Let us have in our mind that the log, when we introduce the log we introduce must have a base 5, so that now it becomes uniform. So what you do, you start by introducing the word log into base 5, log something which we don't know into base 5, then you equate it to 0. So it means where there is 0, we are going to replace that 0 with log k base 5. Log k base 5. We don't know the k, but we can be able to find the k. So we will change this particular log k base 5 equals to 0 into index notation. So this one will be the same thing when we say the base remains the base, the quotient becomes the power, and the number k becomes the quotient. We know any number from indices having a power 0 is always 1. That means if you take 9, you raise it to power 0, you will get 1. If you get 1 million, you raise it to power 0, you will obtain 1. Therefore, this means we will have 1 as our k. Now, this means where we have log k, we will now put 1 into base 5. This will give you 0. That's what it means. Where there is 0 here, we will now substitute the 0 with log 1 base 5. So you will see me coming here and saying we have log 3x minus 2 into base 5, then plus log 2x minus 2 minus 1 into base 5 is equals to log 1 into base 5. Instead of 0, I've just used log 1 into base 5. I've used log 1 into base 5. Now, once we have done that, from the basic knowledge that I gave you, where we have a positive sign, we will change that one to become a times by factoring log 5 outside. Then we open the bracket and say we have 3x minus 2 times 2x minus 1. I'm multiplying the 2 because of the sign, which is addition. Then we say this one is equals to log 1 into base 5. Then now the log and the log there will cancel out. So we now need to expand this. So we will say 3x into 2x minus 1. I'm taking 3x to open the other bracket. I will come back and use minus 2 to open the same bracket, which will be equivalent to 1, which is remaining on our right hand side. When we open the brackets, we will obtain 6x squared minus 3x minus 4x plus 2 is equals to 1. Minus 2 times minus 1, it becomes a positive 2. Putting like terms together, we will have 6x squared minus 7x. Now let's bring this 1 to the other side. It will become 2 minus 1. So this is 6x squared minus 7x plus 1 is equals to 0. We have obtained a quadratic equation. We can use factorization methods to solve that by coming up with sum and product. Sum is always the coefficient of x. The coefficient of x in this case is 7. Coefficient of x means the number that is just behind that particular x. Then product, we know it is a times b. A being the coefficient of x squared, which in this case is 6. Then c being the constant. I'm sorry there. Product should be a times c. C being the constant, the number that does not have any unknown letter. That is 1. That is, when you multiply 6 and 1, you will obtain 6. Now we think of two numbers. When we multiply the two numbers, we obtain a positive 6. And when we add the two numbers, we obtain minus 7. When we think very fast, the numbers will be minus 6 minus 1. Last time, when I was taking you through quadratic equations, I said that for you to be able to obtain these two terms, these two numbers we are looking for, you go to the number that you have obtained under the product, you try to look for its multiples. The multiples of 6 are 6 times 1. You can obtain 6 by taking 3 times 2. And there's no other way you can obtain 6. Those are the two ways. The two numbers, when you multiply them, you get 6 are 1 and 6, 3 and 2 only. But here, we are adding a minus. So, you will now play with those numbers. Say, if you give 6 a negative sign, minus 6 times 1, will it give you a positive 6? It won't. So, what if you put a minus on 1, then you multiply the 2? Can you obtain the positive 6 we have there? Yeah, we obtain the positive 6. When you add the 2, can you obtain minus 7? Yeah, you do that. So that is how you can obtain the factors we are looking for, or two numbers we are looking for that can be substituting the minus 7x that we have there. So where we have minus 7x, we will remove that minus 7x and instead use minus 6 and minus 1. So we will say 6x squared minus 6x minus x. People want me to put 1 here, but we don't always say 1a or 1x. We just use x. When we have 1x or you have 1y, we don't put 1y. We just say it is a y. Then plus 1 is equals to 0. You now close into brackets 2 terms each, and then you ask yourself, is there a common factor in the first brackets? Yeah, 6 is common, and at the same time x is common. 6x goes to 6x squared how many times? It is x times. because 6 and 6 will cancel out, x will cancel with 1x, because x squared means it is x times x. 1x will cancel with this x and will remain with only x. Then minus 6x divided by 6x becomes 1. Common factor there is a minus 1, which will be, this minus is what we have here, and the common factor in this other bracket, that's x plus 1, is just 1. So we will now have x minus 1. What will guide you, the sign you get here, is the first sign you obtained here. By then we just we change this positive to a minus, so that when we reopen the brackets, a minus times a minus will give you the positive that you had initially. Then this one will give you 0. So we now first start by taking the numbers outside the brackets, which are 6x minus 1. And then, since these two terms are the same, we pick 1. That will give you 0. So that means 6x minus 1 can be equated to 0, or x minus 1 can be equal to 0. We take this minus 1 to the other side, we obtain 6x is equals to 1, or x is equals to 1. We have already gotten the value of x on the other side. We can divide by 6 on both sides here, so our x becomes 1 over 6, or the value of x can be 1. So those are the two values of x. Remember, the question wanted us to find the value of x, and that's what we have obtained. Being that we obtained a quadratic equation in any given point here, then it means the values of x that we must obtain should be 2. If we were to obtain a linear equation, then it means the value of x that we must obtain must be 1. And if you are dealing with a cubic function, the values of x you obtain are 3. So that's what will guide you. Now that we have done that, we can go direct to our second example, which is saying log x into base 2 plus log 2 into base x is equals to 2. Look at that particular question that we are given. Are the bases the same? The bases are not the same. So I will prefer we change the bases so that now they are equal. So this question is reminding me of the concept that I've not talked about. But when you have been given log b into base a, this can be the same as saying 1 over log a into base b. So this is another concept that is coming in under further logarithms. But when you have log b into base a, this can be written as 1 over log a into base b. Now you can be able to interchange these two numbers here when you now introduce 1. Then this means we can change that by saying log 2 into base x is the same as 1 over log x into base 2. So once you do that, using this particular concept, you will come back and say log x into base 2 plus 1 over log x into base 2 is equals to 2. You now say let log x into base 2 be a known letter. We can think of k. Therefore, it means when we have these kind of logs, we will remove log x into base 2 and represent it with k. So we will have k plus 1 over k is equals to 2 over 1 over 1. The easiest way is to come up with the LCM. LCM of 1 and k is just k. 1 goes to k how many times? K. K times k is k squared. K goes to k once, so 1 times 1 is 1. 1 goes to k times. K times 2 is 2k. Since we are dealing with an equation, you ignore the LCM. Therefore, we can rearrange that one to form a quadratic by bringing 2k back to our left hand side, and it becomes a minus, then plus 1 is equals to 0. So we can solve that particular function. Now that we have obtained k squared minus 2k plus 1 is equals to 0, we can use factorization by coming up with sum product. Sum in this case is minus 2. Product is 1. Think of two numbers. When you add them, you get minus 2. And when you multiply them, you get plus 1. In our previous example, I said that the number you have in the product will guide you. We have 1. How do we obtain 1? You can only obtain 1 by taking 1 times 1. There is no another way you can obtain 1. But when you add 1 and 1, will you get positive 2? No, you cannot get positive 2. If you introduce a minus here, then you say minus 1 plus 1, will you get positive 2? I mean minus 2. Yeah, you cannot. Then it means you will introduce a negative sign to put ones that we have, so that now a minus 1 times a minus 1 gives you a positive 1, because minus times minus is positive. 1 plus minus 1 plus minus 1 will give you minus 2. So those are the numbers we need, minus 1 and minus 1. Those are the two numbers we need. So we will now remove the minus 2k there and replace it with minus 1 minus 1. Therefore we will say k squared minus 1k minus 1k then plus 1 is equals to 0. So you now put your brackets and then you ask yourself, is there a common factor here? Yes, k is common, which will be k minus 1. Then minus, we have 1k plus 1. 1 is common, so which will give us k minus 1. Therefore, we start bringing together the numbers which are outside the brackets. In this case, we have k minus 1. Since these other two numbers are the same, we now take 1. We only take 1, then we go to 0. Since these numbers are the same, so there's no need of us equating this one to 0 and coming to equate this one to 0. We can equate only 1. Like k minus 1 is equals to 0, meaning that our value of k becomes positive 1. Remember, this is not the answer. This is the value of k that we have obtained. We will go back to where we said let k be log x base 2. So that means our value of x will be log x into base 2 is equals to k. But you will see me replacing this k with 1 because that's what we have obtained. So I will say 1. So for us to be able to obtain x, we will change this particular logarithmic notation into index notation. The base is 2. I said that the base will remain the base. The quotient becomes the power. And the number we have here becomes the quotient. 2 raised power 1 is just 2. So that's how you obtain the value of x. That's how you obtain the value of x. I want to proceed and give you another example too. Let's think of another example too. Simplify. Then you have been given log that 2 into base 2. You are adding log 81 into base 3. So when you look at this kind of equation, the logs given do not have the same. They do not have the same basis. If they do not have the same basis and you have been told to simplify, it means that when you simplify the first log, the log will disappear. How? So that's what I want to show you. So when you have log that 2 into base 2, we know that 2 can be written in index notation because we know that 2, allow me to write here, that 2 can be written as 2 raised power 5. So that means when you have been given log that 2, you can change it into log 2 raised power 5 into base 2. And when there is a number having a power, the power can be written behind log. So it will be 5 log 2 into base 2. And that is a basic knowledge that I gave you. But when you have been given a log b into base b, when these two numbers are the same, that is just 1. So that means for this case, it will be 5 times 1, which gives us 5. As you can be able to see, the log has now disappeared. So can we try to simplify log 81? Yes, we can do it. So log 81 into base 3 can be simplified as, remember, 81 can be written into base 3 as 3 raised power 4. So that means the log 81 to base 3 can be written as log 3 into base 4. I mean log 3 raised power 4 into base 3. Then we bring 4 behind the log. And since these numbers are the same, you will see me saying, but log 3 to base 3 is equals to 1. So that now I can comfortably say that 4 log 3 to base 3 is the same as 4 times 1, which is the same as 4. For this one, we obtained 5. For this one, we have now obtained 4. So when you add the 2, you get 9. So that means log 32 to base 2 plus log 81 to base 3 will finally give you 9. My last example for today under further logarithms will be example 3, which says given that log 2 is equals to 0.10, and I've put a comma here, so there's no need of me saying and log 3 is equals to 0.4771. Find log 0.12. So that's another example I want us to look at together, so that we can be able to learn a certain concept which is very, very, very essential for you as a learner. Log, I'm giving you a solution here, so it's better I use under there. That's when the English will become correct. Given that log 2 is equals to 0.3010 and log 3 is equals to 0.4771, find the log of 0.12. Log 0.12 can be written as log 12 over 100. So you can change the decimal into a fraction. Then from there, we know this can further be written as log 12 minus log 100, because these are division. So if you want to introduce log, then the division becomes a minus. Can we further simplify log 12? Yes, we know 12 can be written as 3 times 4. Because we don't have 4 there, so it can be written as 3 times 2 times 2. Now, we can come here and say log 12 can be written as log 2 times log 2 times, log 2 times 2 times 3. When we have a division and we want to introduce logs, so we will now use addition. This will be log 2 plus log 2, then plus log 3. Remember, we have log 100 on the other side. What I want to remind my learners is that when the bases are not given, automatically it means that those logs are having base 10. The basis of these logs is not given. Automatically, when they are not given, you should understand that the base that is there is 10. So, because we have the power of log 2, we will put it. Log 2, we have, so log 0.12 will be, log 2 is 0.3010, then plus 0.3010, then plus log 3 is given as 0.4771, then minus log 100 is 2. I'm going to show you why. That's what I want to show you. Log 100, remember I said that if the log is not having a base, that's base 10. But 100 can be written as 10 squared, then into base 10. The power comes back here, so it becomes 2 log 10 into base 10. When these numbers are the same, I said that's one. That log 10 into base 10 will be 1. So 2 times 1 will be 2. That's why I've put 2 there. And remember, 2 is a characteristic. And then this part is a mantissa. The whole part of our logarithm is always a characteristic. Now, I will come back here and say and add. We have 0.3010, 0.3010, which will give me 0.6020. Then I've taken this one first, which is giving you 0.6020. Then plus 0.4771, which will give you 1. This will give you 9701. Then minus. I know many of you will use a calculator at that given point, which is very wrong. 2 is a characteristic. You will put it here. Then you now minus. This will be 1970. 1 minus 2 is per 1. So this is the correct answer for this particular question. Under further logarithms, I've given you the content that you require. If you have any question, kindly go down to the comments. Comment there by asking your question. I'm going to answer you. I want to thank you so much for your support. You are the reason why Mwalimu Nyambane channel is where it is today. God bless you for watching. Keep sharing the link so that many people can support this channel by subscribing. Thank you. See you next time. Bye bye.